Hello everyone. In this video we're going to talk about the complements and the conditional probability. Complements is the sometimes we call the probability of at least one. Okay, so at least one is equivalent to one or more, right? And therefore we can actually use that idea to make the calculation easier. Okay. So the complement of getting at least one of item of the particular type is, okay, I think I'm missing something there, but that's okay. Is the you get no items of that type, right? In other words, that you subtract 1 minus probability of none. Okay, so that's what the idea is. Okay, now this cannot be applied to like at least 2, at least 3. That doesn't work. It only used for at least 1. Okay, so let's just make sure that we cannot use any other place except if you have the at least 1 problem. All right. So let's look at some example here. Okay, that's not good. So let's say we have 4 multiple choice questions. So let's see, question 1, question 2, question 3, and the question 1. So each question has, let's say, 4 answers there like this. Okay, same thing for the question 2, question 3, and the question 4. So let's assume that these are 4 totally different questions. Okay, so what we want to do here is that we want to find the probability of getting at least one correct. Getting at least one question correct. Okay, so that means that we can apply the complements rule, right? So that means that we can say 1 minus probability of no question, okay, correct. So in other words, that you don't get any questions right. So if you look at this one here, each one has a 25% probability. So if because there's only one right answer there, so that means that the right answer, okay, is going to be 1 out of 4, or about 25%, right? 0.25. And the wrong answer is going to be 3 out of 4. Okay, so that would be a 0.75. Okay. Remember that the each question has the each question is independent events, right? Because they are totally different ones, right? So in order to find the at least one is correct, we're going to have to find out what is the probability of all wrong, right? No questions right, correct. Okay, all wrong. I mean, that's the same thing as a no correct answer. Okay, each question has what? 0.75 probability. So you're going to have to multiply this, all of them, right? Because they are more independent events. Ooh, hang on. I'm going to have to do this again. So you got 0.75 and the 0.75, then the 0.75, okay, and the 0.75. Okay, so that would be the probability that you're not going to get any question correct. Okay, so let's find out what this is. So we're going to multiply 0.75 4 times. Whoop. Okay. I have about the 0.3164. That's the probability that you'll get all wrong. So in order to find the at least one correct, you just have to subtract that from 1. So 0.3164. That's going to be equal to about 0.68. That's about 68%. Okay, so 68% probability that at least one is correct. Okay, so that's pretty high. I mean, you know, we're not talking about all 4 questions, but at least one. Okay, so that's what we call complements. Now, next one is called the conditional probability. Now, we talked about this a little bit when we talked about the dependent events, right? Because when you have a dependent events, okay, then you multiply the event A to the what we call conditional probability. Because if you go back to the dependent event, oops, hang on. In the dependent event, we had if probability of A and B, then we had the probability of A times probability of B slash A. But in the most examples that we have done, we did not actually calculate the probability of the second part of this. Okay, you know, because we kind of use the intuitive approach. Okay, like, you know, you without replacement, you reduce by 1, those kind of things. So, but actually, this is called the conditional probability. So what it means here is that if you look at the event B and event A, what it means is that event B is going to be your second event. Event A is your first event. So event A happened already. Then next event B happened after the event A. Okay, so if that's the case, then we're going to have to use this formula here. So probability of A and B divided by probability of A. Now it is important that this is for event B is happening after A. If you switch these two letters, then this is the bottom one is going to be probability of B. So be careful when you use these letters, because they do make a difference. Okay, if you switch them, then you're going to have to switch the denominator. Okay, so whichever is the happen and first, that goes at the bottom. Okay, so let's take a look at the example here. So this is the Titanic problem that we did in class. So if you look at it, we want to find the probability of randomly selecting a man given that the selected person died. So I'm going to write this using the problem set here. Okay, so you got, the question is this: probability of man, okay, given that selected person died. Okay, so that's going to be the probability. So the second event, I'm going to call it B. So that's going to be a second event here. And the died is the event A. So what we're saying here is that, you know, we have a lot of men died on that Titanic. So let's assume that we have all the bodies recovered and that they all put them in the body bag. Okay, so then you go onto the deck. Then you blindfold yourself and you randomly select one body bag and you open it. Okay, and the question is, what is the probability that you will see the man's face in there? And that's the question. Okay? So that means we're going to have to look at the formula that we just have here. So I'm going to write that here. So you got probability of man and died Okay, then we are going to have to divide this by the probability of A, in this case, died. Okay, so if you look at the table there, how many men got killed? Well, there are total of 1360. Okay, so we have 1360 out of 2223. Then the total people killed, okay, is 1517. So you got 1517 divided by 2223. Now you can cancel out the 2223. Okay, so now this becomes 1360 divided by 1517. Okay, so let's find the probability here. Okay, so you got 1360 divided by 1517. I have about 0.8965, 0.8965. So we're talking about around 90% probability. I mean, that makes sense, right? Because there are more men died on that accident than any other gender, right? So it is quite reasonable that when you go onto the deck and you select one body bag, you open it, then chances are you're pretty good that you will see a man. Okay, so see, the one thing that we're going to have to be careful here is that conditional probability, we are talking about sequential events. Okay, so one happened already, then happening, what next event happening after that. So it is not simultaneously happening, but it's going to be more like a sequential events that's happening now. Okay, all right. So we'll talk about more topics as we move forward. I'm going to make more videos. So, but I think I made all the videos that would cover the exam 1. Okay, so if you want to have any request or something that you want me to create on the YouTube video, just talk to me in the classroom, then I'll be happy to make one for if you have any questions, or if you think that it's a good idea, then just tell me, then I'll make another one. Okay, all right. So next video I am going to talk about distribution. So that will be a few days from now, then you will see those, okay, after the first exam. All right, thanks for coming. I'll see you in the next video.